everybody. It's 10 p.m. Pacific Time, and it's time for Nighttime Mathematics Radio. So, as always with Nighttime Mathematics Radio, the show works the same way. Tweet your questions into Night Math Radio on Twitter, and I'll try to answer them right here live on YouTube. So, to get started here, I'll take a few minutes to let people log in, ask their questions. For the moment, this is Nighttime Mathematics Radio. Once again, this is Nighttime Mathematics Radio, coming to you live on YouTube. So if anybody has any questions, we'll go on with them. Otherwise, I'll answer a few questions that came in over the week. And these are, once again, about mathematical optimization. This is something that's very tricky to do for a lot of students. Let's take a look. These are typical calc questions that come up around the end of differential geometry. So let's look at this question. We're told that the trough in this figure is to be made to the dimensions shown. Only the angle theta can be varied. So we're shown a long parallelogram prism trough. We're shown that this thing is 20 feet long, is 1 foot across at the bottom, is 1 foot across each of these sides, and all we're allowed to vary is this angle theta, which we define here. So what can we do? How can we handle this thing? Well, here's what we can do. Remember, for any kind of prism shaped like this, the volume is going to be equal to the length, 20 feet, so the length of the thing, times the area of the front surface, which will obviously be a function of theta. What is A of theta? Well, what is the area of a parallelogram like this? Sorry, I'm losing my mind. I'm saying parallelogram when I mean trapezoid. That's embarrassing. Well, what can we do here? We can see it's made up of three pieces. It's made up of this rectangle here and these two triangles. So I believe the formula that you can memorize is that it's 1/2 times the average of the base, 1/2 times the sum of the bases plus the height. But we can even just break this down into its component pieces here. What we have is 1 foot times this height for this square part in the middle, the rectangular part in the middle, I should say. So that's 1 foot times 1 foot times cosine theta. So this is the hypotenuse, so adjacent over hypotenuse is cosine theta. Multiplied by the hypotenuse, that gives us the adjacent side. Plus twice the triangle itself, which is going to be base, which is up here. That's 1 foot sine theta times 1 foot again cosine theta. So there's what we've got. Now every piece of this has 1 foot. We could factor out the 1 square foot times cosine theta plus 2 sine theta cosine theta. And that 2 sine theta cosine theta should be ringing a bell, of course. That's the double angle formula for sine. So that's 1 foot squared cosine theta plus sine 2 theta. That's kind of cute. So the volume as a function of theta is 20 cubic feet times cosine theta plus sine 2 theta. Now we will find the maximum of this as a function of theta, so we need to take a derivative. So dv d theta is equal to 20 cubic feet times minus sine theta plus 2 cosine 2 theta using the chain rule. This is nice. Why is this nice? Well, if theta is 0, that is if this thing is straight up and down, initially this piece is positive, this is 0 when theta is 0. So initially this thing is initially the thing is positive. So as theta is 0, this thing is growing. So we're just looking for where the sign change happens. So what we're looking for is, where is that equal to 0? We're looking for the critical point. So where is 20 cubic feet times, now let's reverse this to make it a nice subtraction, minus sine theta equal to 0. Well, we can divide both sides by 20 cubic feet, so the answer is this happens whenever 2 cosine 2 theta is equal to sine theta. Now where does that happen? And this is a little bit messy. Can we get this? Let's see. Can we get this numerically? Let's see. The answer is probably not. Well, let's see. Let's write this out. What is 2 cosine theta? What is cosine 2 theta? Well, there's the next double angle formula for that. That's cosine squared theta minus sine squared theta. It's equal to sine theta. Now, clearly, we want to get everything in terms of sine theta, so we can just do the algebra here. Well, remember, sine theta plus cosine theta equals 1. Just writing on this. I'll write this on the side. We know that sine squared theta plus cosine squared theta is equal to 1. So cosine squared theta is equal to 1 minus sine squared theta. So plugging that in, we get twice 1 minus 2 sine squared theta is equal to sine theta. Draw a line so I don't get confused where that is. Or 2 minus 4 sine squared theta is equal to sine theta. Let's move everything onto Let's move everything onto the same side of the equation. I'll move everything over there. We get 0 is equal to 4 sine squared theta plus sine theta minus 2. What is this? Well, this is a quadratic equation in sine theta. So it tells us exactly where sine theta. So this is 0 wherever sine theta is equal to minus b minus 1 plus or minus square root of b squared, 1, minus 4 times A. So 4 to 4, 16. C is negative, so it becomes positive, plus 32 over 8. So we know sine theta is equal to minus 1 plus or minus the square root of 33 over 8. So, where does this make sense? Well, is this going to be a fraction? And the answer is yes, this will be a fraction. How do I know this? Because the square root of 32 is going to be between 5, which would be the square root of 25, and 6, which is the square root of 36. So this number is between 5 and 6. So whether this is positive or negative, this is going to be less than 1. So there will be a solution there. Moreover, this is a geometric problem. Remember, the theta here isn't some abstract theta. Theta is this angle right here. So it's got to sit between 0 and pi over 2, which means we can ignore the negative sign. We're looking for something where it's going to be a positive number. So let's ignore the minus. We're looking for the answer where sine theta is equal to the square root of 33 minus 1 over 8. And so we know what theta is now. Theta is equal to, in principle, the arc sine of that number. All we can do now is say, well, what is that approximately? And at this point, it's time to haul out a calculator. I have one right here as it happens. Turn it on. Clear it. So what we have is the square root of 33. 33 square root minus 1 divided by 8. 0.59. We want the inverse sine of that. Let's see, we're in degrees now, which is fine. So it's going to be about 36.4 degrees. This is a nice problem because that's a non-obvious answer. That's not something you would have just noticed if you'd looked at the problem. This is an answer that is not at all obvious just looking at what's happening. But that's actually the optimal solution. So if you were actually going to build such a thing, that's what you'd be shooting for. This is Nighttime Mathematics Radio. Once again, if people have any questions on Twitter, feel free to tweet to Night Math Radio on Twitter. And we'll try to answer them right here live on the air. I'm going to take about a 5-minute break, let people dial in if they want to. So once again, if you have any questions, feel free to tweet them to Night Math Radio on Twitter, and I'll try to answer them live on the air. Once again, this is Nighttime Mathematics Radio, bringing you the best math and the worst loops Apple has to offer. If you have any questions, please feel free to tweet them to me here on Night Math Radio on Twitter, and I'll take a shot at trying to answer them for you on the air. Well, everybody's looking like a quiet night here on Twitter, so I think I'll wrap up the show a bit early. If anyone has any more questions, or you can always tweet them to Night Math Radio. I'll go over them on next week's show. Good night, everybody. This has been Nighttime Mathematics Radio.